Hi, my name is Lei Hua. I'm the apps guy taking care of the system level protection devices. So for this CES show, we built two demo units to show the surge performance and also the performance of our hot switch. You have a lightning surge event. So as we all know that Semtech offer a variety of protection devices. For example, the real clamp for high-speed signal line, and for the micro clamp and the P clamp is for the V-bus line. P clamp is using a PN junction, which is pretty old technology. So when you have a EOS event, the Zener breakdown will happen. So basically, the P clamp device using the Zener voltage to clamp the V-bus line voltage. So we have this first demo unit. We have the P clamp 2011P, and we have another product called SurgeSwitch is TDS 2211P. So we know that the P clamp utilizing the Zener breakdown to clamp the V-bus voltage. Zener breakdown has lots of disadvantages. So for example, the clamping voltage vary with temperature. So if you have higher ambient temperature, the clamping voltage goes higher. If you have a lot more current flowing through the device, and the clamping voltage also goes higher. So that gives us a lot of tolerance on the clamping voltage. To overcome those disadvantages, we come up with a surge switch. So inside the surge switch, we have a reference voltage, we have an op-amp, we have a driver circuit, and we have a shunt device. So the four elements work together as a closed loop to clamp the voltage. So because the closed loop gain is pretty high, so the clamping voltage is always as close as possible to the reference voltage. No matter you have ambient temperature minus 50 or ambient temperature 125 degrees C, the clamping voltage always stable at whatever specified on the datasheet. And also another feature for this surge switch is the surge current. You can see here the yellow line is a TDS 2211P, and the current is just two blue line. And this clamping voltage, the red one is a P clamp 2011P. So you can see when you have a surge voltage keep going up gradually, and the clamping voltage keep going up, and then it's clamp. The P clamp you see is flat at the beginning because the current is low, but current goes up, you see the hump shows up. But our surge switch always flat, so you can see there. So see the surge switch is always flat. Even you have a low current, and then current goes up, it goes up higher, and then still the clamping voltage is still the same. That's pretty much the major difference of this surge switch and the P clamp product. The next one I want to show is our eFuse. It's called HS2240. Inside the eFuse, we have a TDS2211 integrated with the low switch on the front. So this TDS2211 can handle a lot of surge currents and can survive extremely severe lightning surge event. So you can see we have a battery inside. We power up this LED, and then I do the rotation here. You can see the spark. So the light turns off because it's triggering the OVP event. But after the OVP event, you can see the light come up again. The switch still okay. So even you have like 20K voltage across this input of the 2240, so the device still survive. That means that our eFuse HS2240 is very durable for any kind of hot swap applications.